In this video, I'm going to conduct an experiment to determine the refractive index of a triangular prism. Let's begin. You are provided with a triangular prism, a drawing board, drawing sheets, 4 optical pins, drawing pins, and other necessary materials. As a candidate, you have to provide your own ruler, pencil, and protractor for this experiment. Use the diagram above as a guide to carry out the following instructions. Now, it's advisable to fix the drawing sheet on the drawing board by the help of the drawing pins. Draw the outline ABC of the prism provided on a drawing sheet. So we are going to trace the outline of the triangular prism on the drawing sheet. So we name here A, here B, and here C. Now remove the prism, measure and record the refracting angle A of the prism. So we are going to measure angle A. So we put the baseline of the protractor on this line and the point here on point A and measure, and we have 60 degrees. So the refracting angle or angle A is equal to 60 degrees. And now we are going to draw a line DF to make an angle beta is equal to 20 degrees. So let's put a point here, and we are going to put the baseline of the protractor on this outline and the point here on the point of incidence, and we measure an angle of 20 degrees, which is beta. So we measure from this side and we have 20 degrees here. We put a point there and we draw a straight line from the point of incidence passing through the 20 degrees point. This is D, and this place is F. And the angle here is beta, but beta here is 20 degrees. And now we are going to fix 2 pins at P1 and P2 on the line DF. Then we replace the prism on its outline. We are going to look through the side AC of the prism and fix 2 other pins at P3 and P4 such that they appear to be in a straight line with the images of the pins at P1 and P2. So we look through the prism at the side AC and make sure that images of the two pins are in a straight line, then we put two other pins in that line. Remove the prism and the pins. So this is pin 1, this is pin 2, this is pin 3, and this is pin number 4. We are going to draw a straight line passing through P3 and P4 and meeting the outline at Q. That is the emergent ray. We have J here as shown in the diagram and Q here. And the angle here is gamma. We join F to Q with a straight line as shown in the diagram. And we are going to measure the angle gamma. So we put the baseline of the protractor on line AC and the point here on point Q, and we measure the angle from this direction. And the angle gamma is equal to 59 degrees. Evaluate theta is equal to 90 minus beta, and phi is equal to 90 minus gamma. So we have beta in degrees and it's 20 degrees. We also have gamma in degrees and it's 59 degrees. So we evaluate theta is equal to 90 minus beta. Theta is also in degrees. And beta here is 20 degrees. So 90 minus 20 will give us 70 degrees. We evaluate phi is equal to 90 minus gamma. Phi is also in degrees. And gamma here is 59 degrees. So 90 minus 59 is 31 degrees. And we are going to repeat the procedure for 4 other values of beta is equal to 30 degrees, 35 degrees, 40 degrees, 50 degrees. In each case, we will record gamma and evaluate theta and phi. So now we are going to repeat the experiment, but the angle beta is going to be 30 degrees. The angle gamma will also change. Then we evaluate theta and phi as shown here. And we repeat it for 35 degrees, 40 degrees, 50 degrees, and tabulate the results. And we are going to plot a graph with theta on the vertical axis and phi on the horizontal axis. And we are going to start both axes from the origin 0, 0 and draw a smooth curve through the points. So draw the vertical and horizontal axis. And we are plotting theta on the vertical axis and phi on the horizontal axis. So we choose a scale looking at the values of theta. The least value is 40, the highest is 70. So we can choose a scale of 2 centimeters is to 10 degrees. And we will start from the origin 0. So we have 10 here, 20, we keep on adding 10 degrees. And on phi axis too, with these values, we can also choose a scale of 2 centimeters is to 10 degrees. So from 0, we keep on adding 10. We have 0, 10, 20, 30, 40, and so on. And each box, big box, has 10 divisions. So when we divide 10 by 10, we have 1. So each small box is going to be 1. And this is going to guide us to plot this graph. So for the first point, we have 70 degrees on theta axis. This is 70. And 31 degrees on phi axis. This is 30. One box is equal to 1, so we add one box and they are going to meet here. For the next point, we have 60 degrees on theta axis and 39 on phi axis. This is 30 plus 9 more boxes and they are going to meet here. The next one is 55 on theta axis. This is 50. We count 5 more boxes. 43 on phi axis. This is 40. We count 3. So they are going to meet here. The next one, 50 on theta axis. This is 50. 47 on phi axis. This is 40 plus 7 more boxes. And they are going to meet here. The next one, 40 on theta axis. This is 40. 58 degrees on phi axis. This is 50. We count 8 more boxes and they are going to meet here. So we draw a smooth curve passing through these points. Draw a straight line from the origin to make angle 45 degrees with the horizontal axis and to intersect the curve. So we are going to draw a straight line from 0, 0 and make sure that the straight line is at an angle of 45 degrees with this horizontal. And you can use the protractor to measure 45 degrees from the horizontal. And also remember this box is a square and each angle inside a square is 90 degrees. And the diagonals are going to bisect the 90 degrees into 45, 45. So if you draw a straight line passing through the diagonals of the square, it will have an angle of 45 degrees with the horizontal as well as the vertical. So we draw a straight line from the origin 0, 0 passing through the diagonals of this square and meeting the curve. So the angle between the line and the horizontal is going to be 45 degrees as required. And at the point of intersection, we are going to read the value of theta and phi and record them as theta subscript m and phi subscript m respectively. So the point of intersection here, we project it to theta axis and this is 49. That is 40 plus 9 boxes and we are going to record it as theta subscript m, and it's 49 degrees. And we record the value of phi. We project a straight line onto the phi axis. It falls on 48.5 degrees because we have 40 here plus 8 more boxes and is at the middle of the next box, which is 0.5. So we have 48.5 degrees. Evaluate mu is equal to sine theta subscript m divided by sine a over 2. We know theta subscript m is 49 degrees, and a here is the refracting angle we measured earlier on, which is 60 degrees. So we fix them into the formula. So now we have mu is equal to sine 49 degrees divided by sine 60 degrees over 2. And 60 divided by 2 is 30. So we have sine 49 degrees divided by sine 30 degrees. And when we divide this, we have mu to be 1.509. And to one decimal place, we will have mu to be 1.5. And this value here represents the refractive index of the triangular prism used for the experiment. State 2 precautions taken to ensure accurate results. I ensured that the triangular glass prism was well placed on the traced outline. I avoided parallax by ensuring that all the optical pins were erect. Now B part of the question. I. Define dispersion of light. Now when white light, like sunlight, passes through a triangular glass prism, it bends because of refraction. But not all the colors bend the same amount. Red bends least, violet bends most. So the prism spreads the white light into 7 colors: red, orange, yellow, green, blue, indigo, violet. The spreading of white light into colors is called dispersion of light. So we can define dispersion of light simply as dispersion of light is the separation of white light into its component colors when it passes through a medium like the triangular prism. Now BII. A ray of light moves from a certain medium into air at an angle of incidence 20 degrees. If the speed of light in the medium is 2.0 times 10⁸ meters per second, calculate the angle of refraction in air. Now the speed of light in air is given to be 3.0 times 10⁸ meters per second. So now we are going to use this formula. Sine of the angle of refraction divided by sine angle of incidence is equal to speed of light in air divided by speed of light in the medium. So the angle of incidence is 20 degrees. Speed of light in air is 3.0 times 10⁸, and speed of light in the medium is 2.0 times 10⁸. So we replace them. And when we divide these, we have 1.5 over here. Now let's cross multiply. So we have sine r is equal to 1.5 times sine 20 degrees. And 1.5 times sine 20 degrees is 0.513. And we find sine inverse of 0.513 to get the value of r. So R is sine inverse of 0.513, and which gives 30.86 degrees, which is approximately equal to 31 degrees. Thanks for watching, and don't forget to subscribe for more updates.